Okay, start.
Assalamu alaikum. I am Faria Haq Pushpo, roll number 1905751. And my topic is robots in manufacturing under the course Modern Manufacturing Process. And in my presentation, I am going to um, explain the uses, advantages, disadvantages, and the rise of robots in manufacturing. My agenda is introduction, application of robots in manufacturing, types of industrial robots, the rise of robotics in manufacturing, advantages and disadvantages of robots in manufacturing. Factories started using robots in the early 1960s to handle some of the more dangerous and mundane tasks that humans didn't want to do. They work with unprecedented speed and precision today. Robots perform all kinds of tasks and can be classified according to different criteria such as types of movement, application, architecture, brand, ability to be collaborative. As labor costs rise and competition for low-wage overseas locations increases, more and more manufacturers are utilizing robot technologies. In fact, 90% of all modern robots can be found in factories. If we see the applications of robots in various manufacturing systems, we can see that robots can be used in material handling, including the material transfer and machine loading and unloading. Processing operations like since robot manipulates a tool to perform a process on the work part like spot welding, continuous arc welding, and spray painting. Assembly work to produce multiple product styles, mixture of different product styles in batches, and inspection. Robot positions a sense with respect to the work part and determines whether the part is consistent with the quality specification. Then we can discuss about the types of industrial robots. Mainly, there are six major types of industrial robots used in various tasks. Like one of them is articulated robot. The main advantage of articulated robot is the flexibility and dexterity. They can move and manipulate a variety of objects while performing small tasks with greater speed and consistency than human workers. Then Cartesian or rectilinear or gantry robot. We can see the pictures of some robots. Here, the Cartesian robot can be the cheapest solution for simple pick and place operation or tasks that do not require extensive movement. They are often used in assembly lines for performing simple movements such as picking up and moving bottles. Due to the relatively simple design and mechanic structure, Cartesian robots are fairly inexpensive to make. If we talk about the cylindrical robots, they are used for assembly operations, handling, and spot welding. Their function is similar to Cartesian robots, but may be more preferable in some applications due to their ability to move between required points faster. Then we can see three more types of robots like spherical, Kara, and Delta. In spherical robots, we can say that spherical robots were some of the first industrial robots to be used in manufacturing for construction and other dexterous tasks that requires advanced control. Spherical robots are similar to but more complex than Cartesian or cylindrical robots. Nowadays, though they are becoming less and less popular as articulated robots are more flexible. Then SCARA is an acronym that stands for Selective Compliance Assembly Robot Arm. These robots have arms but behave similarly to a human arm in that the joints allow for both vertical and horizontal movement. However, the wrist has limited motion which give it an advantage for many types of assembly work such as pick and place, fitting, packaging, and other material handling applications. Delta. Delta robots are used extensively for assembly and other applications that require high-speed repetition. They are able to complete highly repetitive tasks such as small part assembly quickly and perfectly each time. This is beneficial not only from an efficient standpoint but in terms of health and safety as well. Now, if we talk about the rise of robots in manufacturing, first of all, we can see a representation of estimated worldwide annual shipment of industrial robots by region, in which we can see that from 2007 to 2017, the industrial robots, the shipment of industrial robots is increasing day by day in Asia, Australia, Europe, and America. Yet, innovation in automation and robotics is happening in pockets across the UK manufacturing sector. The University of Lincoln's National Center for Food Manufacturing and Supplier English Provender, for example, recently announced an R&D project introducing state-of-the-art robotic arm to weigh out powered ingredients with more accuracy and with the overall goal of reducing food waste in the supply chain. Manufacturing sector must continue to cultivate and invest in emerging technologies such as artificial intelligence, cloud computing, and robotics, putting digital change at the beating health of growth strategies and making operations smarter, freeing up workers' time to focus on innovation and creativity. Then we can talk about some of the robotic systems in our manufacturing, like flexible manufacturing. One of them is flexible manufacturing system. A flexible manufacturing system is a form of flexible automation in which several machine tools are linked together by a material handling system, and all aspects of the system are controlled by a central computer. An FMS is distinguished from an automated production line by its ability to process more than one product style simultaneously. At any moment, each machine in the system may be processing a different part type. An flexible manufacturing system can also cope with the changes in product mix and production schedule as demand patterns for the different products made on the system change over time. The main components of an flexible manufacturing systems include processing machines, usually CNC machine tools, a material handling system, a central computer system. In addition, a fourth component of an flexible manufacturing system is human labor. Although the flexible manufacturing system represents a high level of production automation, people are still needed to manage the system, load and unload parts, change tools, and maintain and repair the equipment. Then, here comes the computer process control. Computer process control is generally associated with continuous or semi-continuous production operations involving materials such as chemicals, petroleum, food, and certain basic metals. In these operations, the products are typically processed in gas, liquid, or powder form to facilitate flow of the material through the various steps of the production cycle. In computer process control, a digital computer is used to direct the operations of a manufacturing process. The modern computer process control system generally include measurement of important process variables such as temperature, flow rate, and pressure, execution of some optimizing strategy, actuation of such devices as valves, switches, and
ওকে, স্টার্ট করো। পুষ্প,
sir, CAD means the computer aided design, and CAM is mainly the computer aided manufacturing system, which is based on the computer system to process, store, and display large amount of data, representing the part and product specification. Mainly, the computer-aided design makes use of computer system to assist the creation, modification, analysis, and optimization of a design, so that the final object design is developed as adjustments are made on the basis of this analysis. Once the design procedure has been completed, the computer-aided design system can generate the detailed drawing required to make the object. Sir, after that, we have the computer integrated manufacturing system, CIM, in the next slide.
ওকে, দিস ইজ দ্য ওয়ান।
CIM includes all the engineering functions of CAD CAM and the business functions of the firm as well. The functions include order entry, cost accounting, employee times, record and payroll, customer billing. In an ideal CI, and informational processing functions of the company from customer orders to the design and production to product shipment and customer service. In many ways, CIM represents the highest level of automation in manufacturing. And this is the comparative statement of the advantages and disadvantages of robotics in manufacturing. If we see the advantages and disadvantages, we can see that there are more advantages than some disadvantages. And the advantages of the robotics in manufacturing are higher production rates and increased productivity, more effective use of material, uh, the advantages of robots in manufacturing are higher production rates and increased productivity, more efficient use of materials, better product quality, improved worker safety, reduced factory lead time, higher output, reduction in the number of hours worked on average per week by the factory workers. Where it has also some disadvantages like worker displacement, because robots can perform very sophisticated work too, so that there is a chance for workers replacement and high capital expenditure required to invest in the automation, due to the robots used in manufacturing are very much costly. Thank you.